Good morning, everyone. As he said, I'm Rabimba. A little bit about me. So I work with the Mozilla Research, what we call now mixed reality team. So it's not about just VR anymore. It's VR, AR, and what I'm going to little bit talk about, mixed reality now. I'm also a student at Rice University, so I collaborate with Mozilla during my research work. So with that, let me start. What is AR, VR, or MR? So in the background, you can see Evan Sutherland wearing what we call, Sword of Damocles was one of the first VR devices, as you can see. That was in 1960 almost. And so now, like you see, the concept is really not new. It has been there for like quite some time. But it just caught up because of the hardware advancement we have now. So it was always there, the concept was there, the hardware is not up to the mark to actually deliver the performance we wanted. So for AR, VR, or mixed reality, I'm going to talk about AR and MR just interchangeably. What do we need? For a virtual reality, we need to project somewhere to see something which is virtual. For augmented reality or for anything interesting to do, we need a lot of sensors, we need inputs. So these are certain prototypes in military or different things where you can see they have a lot of antennas, a lot of input sensors, and things like that. Then also we need a way to actually see it, to project it. There are certain iterations of how people actually think about that. Microsoft have their vision of MR, which comes partially in HoloLens. And we have a thing where, like on the top, you can see people think that as a like complete VR experience, immersive. These are all there. Now, but what about the experience of the users? We have a friction of VR ecosystem. When you build on any VR devices, for example, right now you can build for a HoloLens, which is the MR device right now. You can build for Oculus, you can build for Vive. If you build for any one of them, you have to use a certain technology. You can use Unity or specifically their SDK to utilize that. All of them binds you to certain technology and certain ecosystems. If you have to publish a game in Steam, you cannot immediately do that in Oculus, or you cannot, of course, run it in Daydream. So there is a friction of ecosystem. There are gatekeepers who dictate the rules you have to build for your experience and such that. We need to get out of the ecosystem. That's what Mozilla is trying to do. For that, we have WebVR. But WebVR is not without problems. We have certain problems to solve. So first, WebVR is a browser-level technology. It runs in your browser. So the browsers have to be capable to actually deliver the experience they want. It has to be on par with the native experience. We have problem about authoring, tool creation. Whenever we are talking about virtual reality, there has to be users who actually consume the device, consume the experience, and then there are people who are actually building the experience, which are the developers. But then again, we cannot only rely on developers coding everything from scratch. That's why we have frameworks to build the experience. We also need digital authors, digital content creators to come and express their story. For example, Washington Post, NASA, they all created experiences using WebVR on how you can actually walk through Mars. That was the Washington Post VR experience. How you can actually experience 360-degree bombing in Syria in 360-degree, like how you can experience the horror. So these are tools for people to express their opinions. So we need to make it much easier. Then there are social aspects of it. Some of you have seen Facebook or Mark Zuckerberg frequently touting the group spaces where you can go into a scene, you can interact with other people, which is awesome. We think that is awesome. But what we don't like is that binds you to Facebook, that binds you to using their specific app, specific devices, and all those together. Why can't you build that same experience in your web application using open tools? So these are some things to think about. Then we have performance problems and everything. I'll talk about a little bit for all of them. So the stack, how it stands is that the technology is WebVR. So for that, you have certain things. You have frameworks, which is for us, we are going to talk about Aframe, which Mozilla came out. And we are also going to talk about web augmented reality and some examples. So what is WebVR? WebVR is a living specification, a W3C specification, which you can see in W3C. If you just go there and search for WebVR, it's a living specification. So the browser's vendors are actively implementing it, talking about it. There is a W3C group. If you are building something, if you have a new idea, or if you have a problem with an existing idea, I encourage you to go there and participate in the conversation. It's always good to actually get the things right when we are building it. Otherwise, we know what happened later with security in internet, because that came as an afterthought, maybe. So people have actually tried to do WebVR before this all started formalizing. So Ricardo from Google, Mr. Doob, he's commonly known, who created 3JS, he came out with a concept. This is a specific commit back in 2013, before WebVR was WebVR, where you can actually take web and try to do certain things which kind of like a precursor of what WebVR is now. But there were, of course, performance problems, and not everybody supported it. So you needed a standard where everybody supports it. Technology is nothing when others won't support it or you don't have a proper way of consumption. So why can you consume it? Today, these are the devices which support WebVR. They all have different capabilities and different price points. So you have a very low-cost device, Google Cardboard, where you can just slide your phone inside it and you just transport to a virtual reality environment. That's cool, that's awesome for demo, I do that all the time. That's really not that awesome when you have to actually interact with your environment. So VR is as much about consumption, as much about interacting. So we have to do something more. So you have the Daydream headset where you have a controller where you can kind of control things. Then we have more heavyweight contenders here. We have Vibe, which supports room scale VR. We have Oculus Rift, which has controllers. We have Samsung Gear, which is kind of like another version of what Daydream was supposed to be. Now, they all have different price point, and the experience varies a lot. So if you're actually building VR applications, I urge you to first research your audience and think what kind of experience do they want. Now, the advantages of WebVR to traditional VR, what we have mostly now, is that it's open. You just publish your app as a website and give the link to people, and it's open to anybody. So if somebody from India or somebody from South Africa has the same access to that resource as to somebody from US or somebody from Europe maybe. Then again, when you are building a game, do you really want to actually download like a 3 GB file to your PlayStation beforehand, before you're playing? That works pretty well for our consoles, but that probably won't work in a VR scene where you have to traverse through the scene, go to a new scene. Do you really want to download like a 3 GB file in your mobile to actually experience that? Probably not. So it's instant because you are loading the resources and you have different way to actually optimize that. All the web ways applicable here, and it's connected. Internet by default is connected. So you always have access to the resource if you have internet. If you don't, then you don't have access. But there are ways to actually even do that using progressive web app. But I'm not going to talk about that today. So the specification I talked about, if you have any concerns, you can just go to this and you can see the living specification, you can comment on it. Now, what about the browser vendors who support it? So this is a neutral website, so go to webvr.rocks. You can see all the browsers, technologies, all the platforms who support it right now. So if you see, we have quite a lot of people supporting the standard. So right now, if you have in your desktop or in your mobile, Firefox, Chrome, Edge maybe, they all support it. In your desktop, if you have an experimental build of Chromium that supports it, Firefox by default, version 57 just shipped and we support it by default. Now, the newcomers here is that Oculus have come with their Caramel browser, which supports WebVR by default, and it will run in Oculus Rift. But you can also run it from your normal vanilla Chrome. Samsung Internet is a new, and they really support most of the APIs of WebVR. So that's a very good addition to the scene. And for all those devices which are not on board yet, we have the Polyfill to support them. So now I know I will get this question, so I'll get it out beforehand. Apple is on board recently. They're gonna support it in Safari. It's not there yet, but it will be in future. So let's talk about what is happening. So this is your browser and this is your web view. To do WebVR, we have a VR player inside the browser and we use that for our VR implementation. What does it mean? In your browser, we are using the WebGL capabilities to actually expose the animation capabilities. Yeah, that's really annoying. So to actually use the WebGL, Aframe in the backend uses 3JS. But as you can see, using 3JS is pretty daunting. When I picked up 3JS, when I started building just like simple Hello World applications, it was quite a learning curve. Aframe is there to make it easier. So Aframe is a framework which is built on 3JS, but it makes it much easier to actually prototype your VR applications. How easy? So I'll start with the Hello World in Aframe. So just in a blank HTML, you just have to include the script, which is here, as you can see the script. And with just these lines of code, you will have a scene where you have a box, a sphere, and a plane. Now, the Aframe is a declarative language. If you see, we have just designed like box, cylinder, and certain properties and have given them properties that how it should look like. This automatically is handled by Aframe and it will give you a VR scene with VR viewer and everything. I'm going to do some demo about it later. So the advantages of it is that since this is really a web page, it plays nicely with all the existing technologies. You can use your D3 to actually do chart, and inside your chart you can see different components. So D3 works awesome with it. You can use Vue, you can use React. React has another version called React VR for VR experience. So all of this plays nicely with Aframe and WebVR. Now, Aframe is built on a concept called entity component system. So people who have used Unity for game development are familiar with it. So we have an entity and we compose it using these things. So we have a geometry where we define how the entity should look like. We have a material, we define what it should look like. We position it on the frame, we animate it, we move it around, and we close it. So these are the things which Aframe already gives you. But what if I want something more? So these are pretty good, but I want something more. There comes the community. The community can actually build or publish a lot of them using whatever you want. If you have a requirement, you just build it and you can publish it. And you can use others. So these are a very small subset of the components the community has came up with. So you can use any one of them in your project and you have the capability right there. So we thought about actually curating it and do something like Node has for NPM, Node Package Manager. So this is something like a Aframe package manager, you can say. So Aframe registry is a curated list where you can just go and see what are the capabilities you have and you can just use them. For example, if I want a hand controller for vibe or a lip motion, so these are the only two lines I need to include in my script, and that automatically will give me two hands which are controlled by the controller. Then again, you don't really want to always see a visual experience by code. You don't want to always code and just run it and see how it looks like. So we have something called Aframe Inspector, where you open an inspector, you can have a like what you see, what you get editor kind of thing, where you can just move it around and do certain things with it. We have an awesome community, and so you can just go to the blog. We publish it all the time. People, whatever experience people come up with. Some of the examples. So this is very similar to Google's Tilt Brush. This is running in Aframe. It's called A Painter. It's a web page. You can just Google it out. It's called, I think the web URL is aframe.io/apainter. You can open it right in your mobile or in your home, and you automatically get the whole 3D painting experience. You can paint in VR, but you're not installing anything. And it will work on your Vive or Oculus or even in your Daydream. So what I talked about, this makes it very easy to express yourself, to express how the bombing unfolds, how a horror unfolds. This makes much bigger impression on people than just reading about it. You have Journey to Mars, where you can just experience how maybe a rover, you can be a rover. I talked about D3. Imagine using D3 inside Aframe, and now you can explore your data in a 3-dimensional space. That gives you much more space to play with your data and experience it. These are all community-made components. And of course, if you have Aframe, you have blasting game. So we have a game called A-Blast. So these are some of the examples people came out with. There are a lot more. There are tools, there are WebVR studios, there are live tours, a lot of them. But what if you want to get involved? We have a Slack where we have a lot of members. This number is outdated. We now have more than like 4,000 members, I guess. And we have a featured project that is, so every weekly we try to demonstrate what community has made, and we just publish it. Now we're going to go to WebVR. But before that, I thought, since I was told I will have some more time, I thought to actually show you a live demo how, like what I talked about, how easy actually it is to make. So I'm going to use a platform called Glitch. Glitch is kind of like an online web editor where you can just write a code and immediately see it live. So I'm going to, can I read it now? So this is an example scene right now running my browser. So I'm using 2 community components. Hardly any of these are actually coding. So these 2 are community components. So this is my Aframe. And this is a community component called Aframe environment. What does it do? So I want to create a quickly prototype an application. I want to show somebody, and I don't want to actually just create the whole environment for me to define, okay, there will be a tree there, or there will be University of Houston building there. I don't want to create all of them. So this component actually have a lot of presets, and you can build more, and you just define the preset here. So I have defined Japan, and I have defined an object which is a box which will have an asset which is this image. I'll show you what the image is, and a text, Hello Houston. This gives me, let me see, the scene. You can move around, you can see, and to actually show you the power, I won't even go inside and change it. I will change something right here. So I don't want the preset Japan. So this is, I'm using just normal editor, and I did like dream maybe. Now you're in a dream scene. So this is a component, and this is how easy it was for me to just quickly come up with it. Now, other thing I talked about is you want to actually see your experience before just coding, okay, how it works. So we have Aframe Inspector. I want to invoke it right in this page. I did not include one extra line of code. This is all I have here. This is my scene, and I invoke it by Control-Alt-I. That gives me this scene. Now, if I select an object, I have every, I have all the properties of that object. For example, I want to do it like a cylinder maybe, and go back to scene. And let us see if our animation and everything works properly. And it works. So that is how easy for you to author it, and you can actually save it. Yeah, question. It's called Aframe Inspector. It was a standalone tool before, but right now you don't need to do anything. So if you are using any Aframe scene, you just press Control, Alt, and I. It will open the inspector for you, and then you can do that. So not only this, you can just clone this object, create something new, and you can just save it in a different file. So you just export it and use it in your new scene. So that is how powerful it is. Yep.
So this is Mozilla, right? So we're working on Apple and Mac-based.
I'm right now running it in Chrome exactly for this question. So this is running in Chrome. This will work here. This will work in Safari. You won't be able to see it in VR. Safari does not support WebVR APIs yet. It works in Chrome, as you can see. It will, of course, work in Firefox. And it will work in Edge. Surprisingly, Edge has been faster to implement this than Safari. Interestingly. But I want to do something more. And I still don't want to code. I'm lazy about coding. So I want to do something else when I look at these scenes. So I have a different scene, the exact same component. So I have Aframe and have done a new component called event set component. What it does? So here what I have is that I have two text, welcome to your new room, something. Then I have three boxes here. And then I have hand controllers. These you won't able to see because I don't have a controller here. But if you were experiencing it in a VR like HTC Vive or something, you would have two controllers. Why do I need controller? Well, let me see what the scene is. This is essentially my scene. So if you don't have a component which builds the scene around for you, like the environment, this will probably you will have in your room, nothing almost. So I had 4 boxes, and I want to do something with them. So when I look at each of the boxes, it changes the environment for me. So this is not just changing the background. I can mash this up with the previous one, and I can change my environment whenever I look at it. Now imagine, instead of boxes, they are portals to another world, just an implementation. So you just look at this portal and you get transported, or in reality you just change your environment to that. So these are kind of like the very easy things to experiment with. Now coming back to the other part, web augmented reality. Once we are happy with VR, we want to do something more. We want to augment our reality, not only look at it. But unfortunately, web augmented reality in real does not yet exist. We have OpenXR group coming up with the specifications of what it has to be, how the API will be implemented. VR has come a long way, almost 2 years now. People are on board of how it should work. That's why I can show you in Chrome. You will have the same experience in Firefox, and so the specification ensures that your users will have a consistent experience. Not the same with augmented reality yet. But how close are we? This was an example. This was a demo we used, and this was using something called Argon.js. And we tried to see what we can do. So these 3 are augmented objects. Do you see something interesting in the video? Yes, this was in real sun, and we could predict how the shadow will be, and we could implement it. So the shadows are of virtual objects which are not really there, and you can see we can predict how the shadow will be move and everything. And this is running in a browser in real time. Again, talk about devices. This is a little more chaotic now. So we have HoloLens, we have plethora of devices. We had early Google Glass, which was what we tried to call partial augmented reality. We have that has made it really popular, Pokemon Go, which we also want to call partial augmented reality. Why partial? They don't fix your devices. If you fix your objects, if you see here, these 3 are fixed on that position. This one actually using a marker to actually fix that, but we can do that without marker. Apple, Google, and others have ensured we can do that. But the previous experiments were not like that, and we are still not there yet. But where are we?
Notice how the graphics stay locked on the map as we zoom in and out, and even as we look down the streets.
Okay.
Place a Skittle on the map and shoot it to activate a bomb.
This is an example. What is there already? Yeah, I did not envision that sound. And this has been possible for quite some time. This is using a library called ARJS, and this is running in browser. So we are using browser's camera using get user media, and it detects that marker. It uses something called JS AR toolkit to actually detect that marker and invoke that object. So, but in future, this approach might not be enough for us for augmented reality, or what we like to call mixed reality, because
all right, so we'll put
of the
over
capability
here for now. So you can see that as I move around the podium, I'm starting to build up a rough mesh of it. That's probably good enough for now. And we'll put mittens.
So that was kind of early how it used to work. So I don't have control over the sound. So that was kind of what we have in mobiles in the previous slide, ARKit, ARCore. I wanted to talk more about it. So what it does, I'm going to talk more about it here because this doesn't have sound. So, so what is happening in there is that Apple and Google both came up with something called, they didn't come up, they're using something called SLAM, simultaneous localization and mapping, or they're actually using MonoSLAM actually. So it is using your camera to kind of map your environment and detect where the planes are. Now Google had a kind of heads up with it because they had Tango, which actually had hardware sensors. So Google's MonoSLAM can not only detect planes, it can detect walls, other objects as well. Apple's version still detects only planes, but we envision this all will get better. What does it give us? It gives us possibility to track objects and actually anchor them to real-life objects. This was Microsoft HoloLens, which we thought was pretty cool and pretty futuristic, but then again, it's like a $1,500 device and it's not really accessible. But what we want, can't we mimic the same thing we did with WebVR? Can't we mimic the same possibility? Instead of just WebView and WebVR, can't we have an augmented reality thing on it? So there are problems. AR is more than just VR and spatial tracking. It has to be really intuitive. There are other problems. You have to interact with the object. How do you interact with the object? How do you actually interact with that kitten? So these are all the problems. One of the ways to do it is decouple the apps from reality. Think of it as a separate object. And so we have an awesome article from Blair. Blair is a principal research scientist in Mozilla. He works a lot in augmented reality space. He also is a professor at Georgia Tech, where he leads his augmented reality lab. Now, I wanted to, I talked a lot about AR. I wanted to try something like a real life demo. This might not work, this might work. So this is running right now from my mobile. This is a Pixel. This will work in iPhone. As you see, I go. So this is actually a slide, a talk slide, no, not power off. So, and this is running from my GitHub Expo. This is, so bringing mixed reality. This is our new homepage. And this is you. Normal, not too extreme. Now, I guess I'll have to wait. So this was initially in an iPad. So we have an WebVR client application, which works flawlessly in Apple, and I'm still struggling on this one. Okay, let me try it once more. I really wanted to show this. So how I'm running right now, this is at this is a experimental browser called WebVR on ARCore. So this exposes the ARCore capabilities to me, and with them all the goodies. Okay, the internet is really slow. So the page has to load, which is still loading. So there is your first AR object moving around with you. But where are my minions? Okay. So first humanoid here, somewhere. The other one. So this is really not running that well. So what you can do is that, so this is running right now from my browser, and you can use your mobile and actually see them. Whenever I tap, there will be one more object. So the goal was to extend WebVR to augmented reality and have something like,
So you program that object first, and then you are like calling it, right?
yes. So right now the capabilities are pretty limited. So what it does is that it tries to detect the plane, and then it builds on top of it. I have a better demo, I'm going to show that. But this I tried to actually integrate through slide with Reveal.js to show how powerful it is. So a lot of work we have done in WebXR is coming from Argon.js, which was a research project in Georgia Tech. And we took a lot of those work and integrated on what we have now in WebXR. So what is where? So this is an object which is moving around with you. So if you want to use some of it, you can just visit these websites. I will have link of them on the back of the slide because this is really jittery. So this is what I'm using right now to run it in this browser. So now you see the polyfill is really not that great, but it works. So we have VR, so I can actually put it inside a VR scene. This is what is going on. Yes, okay. So this is in a VR scene, and this is you, and this is my object. So if I move around, that same object now is in a VR scene. So the object tracking capabilities can be utilized in other experiences as well. You can have not a maybe room scale, but you can move around. You can have a virtual painting application with just your mobile with object tracking. So these are the mixed reality aspects. Now you can do a lot of things. You can do 3D effects, bloom filters, and a lot of those things. So for more information, you can visit our mixed reality page, but I'm going to go back to my real slide. Oh, not exactly. So I'm going to try to show you something else. This was built literally yesterday. If I can copy it. And so yesterday was a hackathon here, Code Red. So what it does is that, if it works, work. Yep. So I detect this floor, and I want to build a home. So from here to here to here, this is my wall. This is my second wall. Third wall. Okay, somewhere there, and I finish my room. This is running from my web page. You can actually visit that. Now I want a door, maybe from here painting. Okay. Now, the purpose of this was to demonstrate certain capabilities. So I want to see how my furnitures will look in this room. So I press suggest me some furnitures, and it gives you certain furnitures inside that room. I paint them a little bit better. So the interesting part is I can walk between them, see how they look from different angles. I can go to my chair, which is here, right here, yeah. I can go to my table, see them, and look around to see other objects. You see, they will retain their position. This is running right, and it's very jiggly. But this is running right now from my browser in mobile, and I'm streaming them. That's why it's jiggly. It's pretty smooth here. So these are kind of things you can do right now. This is using AR Core's capabilities, but as you see, it's running from the browser. It's using with XR polyfills, and this is just an example of what can be done very quickly.
So where do you pull the library of objects from?
Okay, so about the demo. So the objects were, so there is an awesome place to where you can build objects or just use someone else. These were from Google Blocks and Sketchfab. So there are a lot of already 3D models available which you can use with keeping in mind of the license, of course. And Mozilla right now has a competition going on with Sketchfab, so you can just go around, build your own objects, open source them, and if you win it, you can get a very nice VR capable laptop or an Oculus Vive, depending upon what you win. So that's something to think about. Now, WebXR is supposed to be extending support for WebVR. This is not like reality right now. We have a very experimental app, the WebXR Viewer, which works in iPhone, and it is already given to Apple. It will be published in App Store, so you can just play around with it. It will support the XR APIs. This is still an experimental app, so you will have some sample applications with it. So if you want to learn more about it, just go there. The advantages of having an WebXR API is that you don't have to build for AR Core, or you don't have to build for ARKit, or you don't have to support something. Someday Microsoft will come out in their new version. You support this, and we support how the AR Core or ARKit APIs interact with it. So you have the capability to utilize them regarding of the device you are using. So extending the support brings us a lot of more interesting things. There are a lot of interesting problems to think about, what you can do with these new information, how you can integrate these, how you can improve the experience using maybe machine learning, maybe something else. Just imagine the same experience I was showing you. Some of you may know Google had a demo called for auto draw, where in your web page you just draw something and it used to just give you suggestion, okay, this is the object. Imagine that in a painter. You are drawing something in virtual reality. After you are drawing, the system actually gives you like, okay, you are drawing this model, not just painting. It suggests you a model based on what you are drawing. These are certain things you can do. There are a lot of interesting problems. So this slide, now back to this slide. This is running in Reveal.js, which is an awesome slide platform. But to just show you the capability, we integrated this with 3JS and AR. So the link and everything in this slide is in GitHub, and what I showed you right now in my mobile, you can actually try it out or see in your own slides if you want to. That's all in GitHub. And that also emphasizes the power of having these technologies out in open web, not in closed silos, what you can do with it. So the web ecosystem is rich and diverse. It's not about just building things. You can integrate it with industrial application. You can integrate it with Internet of Things or Internet of anything. So there are a lot of interesting mashups happening, and I really encourage you to go see our Slack channel. People are posting weird ideas, interesting prototypes all the time, and we get a lot of ideas from there to like, okay, maybe this is really cool, let's try it. So, an authoring platform we use, so glitch.com kind of like makes it easy to immediately write your code and see it. Glitch is not, of course, the only one. I used to use CodePen. So there is CodePen, there is JSBean, all of them, if you include, these are just like normal web IDEs. But the plus point is you now don't have to write an app, compile it, run it inside an application. Run it in your browser, just write a code, open another tab, run it, and you can see how your experience looks like. These are certain experiences which you can use for it. This is an example I wanted to show in VR. So WebVR was a project came out of Knight Fellowship Foundation and Mozilla. So if you just go to the website, if you just write certain things there on the left that show me a cool export from there, it will create a VR scene for you. So you don't have to code at all. And I can show you a demo where I can just write, I dreamt about a sunset yesterday, and it will show me a VR scene with sunset in it. So it creates the scenes for you. This is very like basic, but it gets the job done, and it opens you up to the possibilities what can be done. So web is a platform for making anything open, not only AR, VR. Our point is, why not make AR, VR open and accessible to everybody? Web is accessible to everybody. Our mobiles are, expensive devices may not be. So why build for a siloed device when you can actually build for something which will be usable to any device you want? So with that, I'll conclude my talk, and most of the resources I have talked about, you will be able to see in my slide. The talk is hosted in my GitHub repo, and the WebVR APIs are available in our WebVR API GitHub repository. The polyfills, which you will probably use because it doesn't support, almost none of the browsers yet support it, the stable versions. So you will use the polyfill for the stable versions, or Google has WebVR on Air Core browser, it's a really long name, which I'm using for my Pixel, which supports the API. For Apple, we came out with a WebVR client, which is also in GitHub, but will also be in App Store, which you can use for iOS devices, which uses a very tricky method to actually kind of implement it, but it works pretty well for iPads. So you can try some of these yourself, and if you're interested, just you can get in touch with me. I wanted to do a shout out to Blair and Trevor, who are actually implementing all these inside Mozilla. I work in mostly optimization part in right now VR. So with that, I conclude my talk, and if there are any questions, I'll be happy to take it.